Welcome back to the solutions manual. In this video, we will solve the problem 2-57 from RC Hibbeler Engineering Statics 15th edition. According to this problem, if F is 5 kilonewtons and theta is 30 degrees, we have to determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis. Now to solve this problem, first of all, we have to resolve the forces into their components along the x and the y axis. So for force F, we have a vertical component and the horizontal component. For the 4 kilonewton force, we have a horizontal component and the vertical component. This 6 kilonewton force has a single component directed along the positive x-axis, so we don't have to resolve it. Now let's label them. This right here is F sine theta, and the vertical component is F cos theta. If this angle is 15 degrees, it means that angle is also 15 degrees. Because they are alternate angles, so they are equal. So the horizontal component of the 4 kilonewton force is 4 sine 15 degrees, and the vertical component is 4 cos 15 degrees. So far we have resolved all of the forces into their components. So now we can apply summation of forces in x direction and in the y direction to find the horizontal and the vertical components of the resultant force. So for the horizontal component Frx, I am considering right hand side as positive, is equals to summation of forces in x direction. So we have F sine theta minus 4 sine 15 plus this 6 kilonewton force. The Frx becomes F is 5 kilonewtons and the theta is 30 degrees. So 5 sine 30 degrees minus 4 sine 15 degrees plus 6. So upon simplification, Frx comes out to be 7.46 kilonewtons. And since we are getting a positive answer, it means that the Frx is directed towards the right hand side. It means in the positive x-axis. Now we have to find the vertical component of the resultant force, which means Fry. I am considering up direction as positive. Fry is equals to summation of forces in y direction. So we have F cos theta plus 4 cos 15 degrees. And there is no vertical component for the 6 kilonewton force. So upon simplifications, Fry is equals to F cos theta, which means 5 cos 30 degrees plus 4 cos 15 degrees. So Fry comes out to be 8.19 kilonewton. And since we are getting a positive answer, it means that the Fry is directed in the up direction towards the positive y-axis. So now we have to find the magnitude of the resultant force. So we can use the Pythagoras theorem. So for the magnitude of the resultant force, it is equals to square root of Frx square plus Fry square. So we have square root of 7.46 square plus 8.19 square. So the magnitude of the resultant force comes out to be 11.1 kilonewton. So this is our first answer. We also have to find the direction of the resultant force measured counterclockwise from the positive x-axis. So if I draw a resultant force, then it would look something like this. Let's say this is the positive y-axis, this is the positive x-axis, this is the negative x-axis, and this is the negative y-axis. The FRX is directed in the positive x-axis and the FRY is directed in the positive y-axis. So by the head-to-tail rule of vector addition, we have FRX, FRY, and the resultant will be drawn from the tail of the first vector to the head of the last vector. So this is FR, this is FRY, and this is FRX. And since we have to measure it counterclockwise from the positive x-axis, so this angle, let's call this alpha. So we have to find the angle alpha. So we can use the trigonometric ratio of tan. So we have tan alpha is equals to opposite, which is FRY, over the adjacent, which is FRX, and we just have to use their magnitudes. So tan alpha is equals to FRY, which is 8.19, divided by FRX, which is 7.46. Alpha is equals to tan inverse of 8.19 divided by 7.46. If we take the tan inverse of this value, then alpha comes out to be 47.7 degrees. So this is our second answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts, then feel free to ask in the comment section and I will try to answer them as soon as possible.